Good day, everyone. My name is Manuel Landrito, and I am here to present our thesis titled Gesture-Based Television Controller Using PIR Sensor Array. Hand gestures are one of the many forms of communication that people use in everyday life. These gestures can say a simple word or phrase for others. As for this study, those same gestures can be used to control televisions. This allows people to easily use a television if they are within range of the system. The researchers' main goal is to design and test a gesture-based television controller using RPi3 microprocessor for the elderly or the disabled. We have three objectives in this study. Firstly, we'll identify the hand gestures needed to use in the PIR sensor array. Secondly, we'll use the convolutional neural network to train a system to recognize hand gestures. And third is to test the effectiveness of the system. The PIR sensor array that is used has a recommended range of 50 centimeters or closer. The system has only been tested on Sony TVs, and that gestures recognized by the system are already preset and cannot be changed. For our conceptual framework, the system will have an input of hand gestures, mainly hand swipes, wherein it will then process by a convolutional neural network to identify what hand swipe gesture it was, specifically what direction the swipe is. Once detected, it will then output the television control. Now, the television control can either be used to change channels, lower the volume, or turn the television on or off. Here is a block diagram of our hardware, wherein we would have a Raspberry Pi 3 powered. The PIR grid will be attached to the RPi 3. This is where we will get our inputs. The processing will happen in the RPi 3. Once done, it will then send signals to the infrared emitter to control the television, and that would be our output. Here's a picture of the prototype, which is the 4x4 PIR sensor array. Now, each of these PIRs has a designated number. As you can see here in the table, from left to right, we have 1, 2, 3, 4, and it goes on per row up to 16. Now, these numbers will be used to identify which PIR sensor was first triggered by the hand. Here's the experimental setup. It's the same as the hardware diagram, wherein we would have the 4x4 PIR grid attached to the RPi 3 with its GPIO pins. The Raspberry Pi will do the processing, and output will be done through the IR emitter, which the television will pick up. Now, here is the flowchart. Cond 1 here pertains to our power source if it is active. So if condition is or cond is equals to 1, the prototype will try and find the inputs of the PIR sensor. Once it has found the inputs, it will be put into the created algorithm to be able to recognize the hand swipe. If it is recognized, it will then interact with the television. Now, if cond is equals to 0, it means there's no power. and that is the only time the prototype will deactivate. Here is our data gathering. So we have 8 different gestures: up, down, left, right, up left, and down right. Each would have a pertaining action or command, such as increasing or decreasing volume, changing channels, muting the television, and opening and closing the TV. Each of these gestures will have 50 swipes done for the training. So we would have a total of 400 swipes for all. Here is a sample of what the data would look like for a right swipe, left swipe, or a left down swipe. As you can see in the picture, we would be having a right swipe, and that it will first come into contact with the leftmost PIR sensors. So the first sensors that will get activated is 5, 9, 13, and 1. This will correspond to the leftmost PIR sensors. 5 here, 9, 13, and 1. So this is the structure of data that the RPI-3 will see and use to determine the direction of the hand swipe. Here are the results of the prototype. As you can see here, the up, down, and left have a accuracy that is above 60%, whereas the others are mostly 50% and below. So after averaging this, we will have a 55% general accuracy for the entire system. A device was created that can detect hand swipes and control the television. It has overall low accuracy of 55%, wherein horizontal and vertical swipes are more accurate than diagonal ones. Now, the researchers believe that the low accuracy is due to the following. The 1D CNN algorithm used is not suitable for this application. The user's varying speeds when swiping can affect the results. The PIR sensors are delayed when on testing, as observed, and that there are too many directions for swipes. Therefore, the researchers recommend the following: a different algorithm besides 1D CNN to reduce the amount of directions being tested, as their data can overlap with one another. Next is to change the formation of the PIR grid to something more suitable or easier. Next is to change the PIR sensors used for better responses and less delays. Next, we'll be moving on to the prototype demo.
Hello, I'm Axcel Abanilla, and it's going to be the video demonstration for our prototype for the gesture-based television controller using PIR sensor array. So as you can see here in the video, we have the prototype which has the 16 PIR sensors arranged in a 4x4 grid, and in front of it is a television where we will see the commands in action after doing the swipes. So there are 8 swipes in total, but only 6 commands. So because 2 pairs of the commands, which are the diagonals, share the same action or command. So the up and down swipes are for the volume, and then the left and right commands or swipes are for the changing of the channels, where previous and the next channels, and then the up diagonals are for opening the television, and the down diagonals are for muting the television. So we will see those in action just a bit here. So first of all, when we start the video, we're going to see the diagonal for this command or swipe for opening the television. There's also the same for closing the television. So you see there the swipe has been done and the television has opened by the side of the yellow light in the bottom left, and then the television has started opening. Okay, and now that's done. The next command is going to be for the changing the channel. So the first command here is going to be for the previous channel, which is swipe going to the left. So you can see the current channel is 8. I'm going to change it to 7. So there you go, 7th channel. Now next we're going to change it back to the 8th channel by doing the right swipe command. So as you saw there, it's channel 7. Now after swiping to the right, change to 8. The next command is going to be for the volume. So the volume up is going to be for increasing the volume. So you can see here, the volume icon is going to be up here on the bottom of the television. So that means it increased from 8 to 9. And then next, we're going to do it again to show it more clearly. We're going to go from 9 to 10. And then next is going to be volume down. So this one is going to be from 11 to 10. And then again, one more for good measure from 10 to 9. And then, now keep in mind the volume has been set to 9 for now, because you're gonna see why later. So this is going to be the last command that we're going to show. It's going to be the mute command for the television, which is going to be the diagonal swipe again, which is the other diagonal swipe. And then as you can see there on the bottom left, you see that the icon for the mute has come up. When I mentioned the 9 volume just a bit ago, was because in this part, before the muting, you can see that the volume icon appeared again. This is because of the overlap that happens sometimes in the device, the prototype, due to the low accuracy of the device only being 55%. So there are some times that it does a command that is not of it that the one that they're trying to do. So in this case, it increased the volume first from 9 to 10 before muting it. But in any case, the mute command worked, and now the television is muted. So as you can see in the commands that are presented here, there isn't much of a delay in the swiping and the command, as long as the device properly processes the command into what the specific command is. So only due to the low accuracy, we're sometimes going to have a long time seeing an effect. But other than that, the device works and all the directions have been tested. So that's it. Thank you.